Now let's do homework 1 through 8, drawing free body diagrams. A book is at rest on a tabletop. Now if you were to draw this picture, you would have a tabletop. I'm going to put legs. I got a leg back there. And then here's my book. Okay, can't see the forces, so let's draw my book as a block. The first force you always draw is FG. It goes straight down. Now because it's resting on a tabletop, there's going to be this normal force, the force of the table pushing back up on the book. I don't have any forces in X. If I were to write my net force equation for this, I could say F net. Now remember, I say either F net or summation of the forces. It doesn't matter which one you use. This just reminds me that I'm always going for the arrows. And it's at rest, and so it has no acceleration, so this is equal to 0. Now, what do I have going up? I have Fn going up, so Fn is positive, minus what I have going down, and I have Fg going down. Minus Fg equals 0. This is Newton's law for the book on the table. Now I have a horizontal bar hanging from a ceiling suspended from 2 ropes. So let's see if I can draw this. Here's my rope. Here's my bar. Here's my rope. So I have a right rope, or a left rope, and a right rope. A girl is holding onto the bar with one hand. Okay, well here's where we're going to get creative. Here's the girl. There she is, hanging on. Alright. And she's motionless. So I know that there's no motion, so the sum of all my forces is going to be 0. Diagram the forces acting on the girl, and then diagram the forces acting on the bar. Alright, so here's the girl. The girl is a box. And make sure you write girl. First force you always draw is her weight. It's going straight down. So this is Fg of the girl. We'll put G for girl there. Now she's hanging on to this bar. I can call this a force up or a tension. We're going to call that the tension in her arm. So we're going to call that T. Now what if I do the bar? I'm going to go ahead and make the bar kind of long and thin. It's still square. So I see the first thing I'm going to have is the weight of the bar. So this is Fg of the bar. Use a little b. And I also have the girl's weight pulling down. So I'm going to make this really big and go straight down. So this is Fg of the girl. Going up, I don't have a normal force, but I do have the tension in the rope. So this is T left and T right. My net force equations are going to be 0 because it's not moving. For the girl, F net equals 0. Remember to write girl here. So I have tension of the girl minus Fg of the girl equals 0. For the bar, what do I have? I have F net equals 0. And what forces do I have going up? I have T left and I have T right. So T left plus T right minus the forces going down. So I have minus Fg of the girl minus Fg of the bar. And this equals 0. An egg is in free fall from a nest in a tree. So I've got an egg and it's falling. When I have oval shapes, I do tend to make oval objects instead of boxes. The first force we have is gravity, so it's going straight down. So this is Fg. It's not sitting on a surface, so I don't have a normal force. And it says neglect air resistance. I'm not applying any other forces. So this is my free body diagram, and it's of course accelerating downward, and we know that acceleration is 9.8 meters per second squared. What would Newton's law say in this? Sum of the forces equals ma, because now I do have an acceleration. The only force I have acting on this is Fg, and it points down, so I'm going to put a negative sign there. Minus Fg equals m. Now my A is negative, so I'm going to put in negative A. Now watch something. I'm going to multiply through by negative 1. I'm going to distribute that negative 1 to both terms. Negative times a negative is positive. So I get Fg equals ma. Now remember the weight of an object, the weight of any object, Fg is equal to mg. So mg equals ma. My masses cancel. So look at this. I wind up with g is equal to a. Cool. We knew the egg was falling with an acceleration equal to g, which is 9.8 meters per second squared. This is a little bit more work than I asked you to do. Now I have a flying squirrel. It's gliding from a tree to the ground with constant velocity. Constant velocity means my acceleration is going to be 0. And now we have to consider air resistance. I'm not going to attempt to draw a flying squirrel. We're going to draw a box. First force is always gravity. And I know my acceleration is 0. Because my acceleration is 0, I know I've got to have balanced forces. And since I have gravity pointing down, this tells me I have to have some sort of force going up. And I'm going to call this air resistance. Oh, that's too much to write. What does Newton's law say? Sum of the forces equals ma, but in this case, acceleration is 0. What do I have going up? I'm going to call this F, air resistance. And then I have Fg pointing down. All right. A rightward force is applied to a book in order to move it across a desk with a rightward acceleration. Consider friction. Neglect air resistance. So here's my box, my book. First force you always draw is Fg. It's always straight down. Now it's sitting on a table, so you've got a normal force. So when it's sitting on a surface, always draw your normal force in second. Now let's go back to the problem. I have a rightward force applied. So I'm going to apply my rightward force. I'm just going to call this Fa. You can call it just F. And it says consider friction. Because it's accelerating to the right. How do I know that? Because it says rightward acceleration. So friction opposes motion. So friction is going to point to the left. Now a lot of times I use lowercase f with r for friction. Let's look at what Newton's laws say here. Sum of the forces in the y is 0 because there is no motion in y. Ignore everything in x. All right. What do I have acting in y? Just Fn minus Fg equals 0. Sum of the forces in x, and this equals ma. What forces do I have acting in x? I ignore everything in y and just look at my x forces. I have Fa minus friction equals ma. These are Newton's laws written out for this problem. Now let's look at this one. A college student rests with a backpack on his shoulder. The backpack is suspended motionless by one strap. Now we just want the vertical forces. I'm not going to attempt to draw the college student here. Here's the backpack. There is gravity going straight down. We're going to assume the strap is vertical because otherwise it gets a little messy. So this is going to be the tension in the strap. What does Newton's law say? Sum of the forces equals ma, but it is resting, so the sum of the forces is 0 because my acceleration is 0. So I have the tension in the strap pointing up minus Fg equals 0. A force is applied to the right to drag a sled with a rightward acceleration across loosely packed snow. Has a coefficient of friction. Okay, draw your box. First force you always draw is gravity. Goes straight down. Now it's sitting on the ground, so we're going to have a normal force. Normal force points straight up. Let's go back to the problem. A force is applied to the right. Okay, so I'm going to draw my rightward force. To drag a sled with a rightward acceleration, so I have acceleration going to the right, across loosely packed snow, which has friction. Friction. Let's write Newton's laws. Sum of the forces in y is 0 because it's not moving in y. What do I have going up? I have Fn minus what I have pointing down, which is Fg, equals 0. Sum of the forces in x equals ma because it is accelerating in a. What do I have going to the right? I just have this applied force. What do I have going to the left? Friction, so I'm going to subtract off friction, equals ma. Remember, these are your arrows, and this is the result. This is going to be your mass times your net acceleration. All right, the football is moving upward towards its peak. So it gets booted and goes up and comes down. Neglect air resistance, no friction. Diagram the forces as it rises toward its peak. All right, here's my football. Force gravity always goes straight down. We've got that one. Now at this point in time, there's no air resistance. I'm not applying any other forces to it. So this is it. I'm going to have an acceleration going down. What does Newton's law say for this? Sum of the forces equals ma. This is the law. Now let's apply it. Fg goes down, so it's minus Fg. I don't have any upward forces. Equals m. Now a is negative, minus a. So now I want you to draw free body diagrams are given. Now let's see if we can find the net forces. We're going to actually solve these. Always break these into x and y. I usually do y first. In this case, the net force is 0 in both x and y. So if I sum the forces in y, this is going to be 0. Ignore everything happening in x. I have b going up, so the summation is the arrows. So b minus, I have 200 going down, 200 equals 0. I'm going to solve this for b, so I'm going to add 200 to both sides, and I get b is 200. Oops. Now I'm going to change colors to do my y. Okay. Summation of forces in y equals, in x. Let me erase that. Summation of forces in x is going to be 0 because our acceleration is 0 across the board. What do I have going to the right and what do I have going to the left? Well, I have 50 going to the right and a is going to the left. Remember, this part right here is always the arrows from your diagram. So I'm going to have 50 positive minus a equals 0. I'm going to solve this for a. Now I've got this negative here, so I'm going to add a to both sides. And I'm going to flip it around. So a is equal to 50 newtons. Let's look at the second one. I only have forces acting in y. And I see my net force is 900 newtons and it is up. So summation of the forces equals ma. This is Newton's law. You have to write this first. Now, this is the arrows. What do I have going up? I have C going up, and I'm going to subtract off what's going down, which is 200 newtons. You always read these right off your free body diagram. This equals ma. Now, this is also my net force. I can write, remember, I can always write sum of the forces equals F net. So this equals, let me rewrite this, my F net, which is 900 newtons. And since it is up, it is positive. To solve for C, I need to add 200 to both sides. And I get C is 11,100 newtons. Oh, this one's got forces in both x and y, and we have a net force to the left. Let's do y first. It's not moving in y, so the summation of the forces in y is 0. This is again the arrows on my free body diagram. I have 300 newtons going up. What do I have going down? I have E going down. This equals 0. I need to solve this for E. So I'm going to add E to both sides. So I get 300 is equal to E, or 300 newtons is equal to E. I like to write it as E equals 300 newtons. A lot of times I just go ahead and flip it. Now, let's solve this for the summation of the forces in the x direction. Newton's law says the summation of the forces in x equals ma. This is Newton's law. Write it down. Now, this is also equal to F net. Okay. So, let's read off the sum of the forces. I have D going to the right, so it's going to be D. Subtract off what's going to the left, so that's 80 newtons. And this equals F net. So, instead of writing all of this, I'm just going to put my 60 newtons. Now, this is to the left, so that is negative. Now I need to add 80 to both sides because I'm going to solve for D. Add it. So D, those cancel, I love crossing them out, is equal to 20 newtons. Now let's do the last one. We know the mass is 10 kilograms. So when you know the mass, go and put it in there. All right. Let's sum the forces in y first. All I have are F and H. But remember I told you, whenever you have just something pointing down like this, this is the weight. And I have the mass. So let's come over here. I have a mass of 10 kilograms. And in this example, H is equal to the weight, Fg, which is mg. So H is equal to 10 times 9.8, or 98 newtons. So now, sum the forces in y, and it's 0 because it's not moving in y. What forces do I have going up? I have F. What forces do I have going down? I have I have H. This equals 0. So I'm going to add H to both sides. So F is equal to H. And I've already calculated H is 98 newtons. Now I'm going to sum the forces, and it's going to the right. Let me change my pen color. Okay. Sum of the forces in X equals, I'm just going to write this as F net because I've got F net. Sum of the forces, these are my arrows, so I've got G going to the right, minus 20 going to the left, equals 30, and it's to the right, so that's going to be positive. To solve for G, I add 20 to both sides. Add straight down, those cross out, makes me happy. G is equal to 50 newtons. And that's it.